There we go. Hello everyone and welcome to Handmade Hero, the show where we code a complete game from scratch, live on Twitch. We don't use any engines or any libraries, we code everything ourselves here, and that's our goal. This is an educational program. What we're trying to do is basically show how every single part of a game works. And so each day we take an hour to code something, and it's some new part of our game, some new aspect of our game, so that we can kind of see the entire process. And again, I do it all without really any preparation, so that you can see how I would actually approach it, warts and all, in a real professional environment, right? I don't go write the code first and then just type it in here. I actually go through the whole mental process of how do I figure out what to code, how do I debug it when I make mistakes, all that kind of stuff. That's what we do, and it's been going pretty well, so I'm pretty happy with it. And we've got plenty of stuff that we've got to do, so let's go ahead and get started. If you have pre-ordered the game on handmadehero.org, obviously you get full access to the source code here, since there is no game yet, there's just source code. So you can go ahead and download that source code anytime you want. You'll get a link in your email. If you have done that, today is day 69, so you want to download, the source zip will have day 68 source code in it. You want to start with day 68's source code, because that's what I'm starting with today. So if you're trying to follow along with today's video, that's the one you're going to start with if you want to code along with me at home. So if I remember correctly, we were right at the point yesterday where we wanted to start talking about doing sort of more collision response code, more handling of collisions. And so what we had yesterday is we had just gotten to the point where when two entities sort of collide on the screen, we know that they do that, right? And then we want to respond to that in some way. And we're about to deal with sort of all of the complexities that come with that collision response. Now, one of the things that we haven't addressed yet, and that was kind of where we left it, was we don't really know what to do with things. We don't really have a strategy for dealing with when things hit other things but should just pass through them, right? So for example, if I had this little test, I could fire this little rock sprite out from my guy as a little test thing that we were doing, and it hits me, and it gets stuck on the edge of me, right? I've got a little bounding box, and when it hits the edge of that bounding box, it gets stuck on me, and that stops it from going forwards anymore because it just keeps hitting me and hitting me and hitting me and hitting me and hitting me, which is kind of what our collision detector is supposed to do. It's not supposed to let things go through bounding boxes, right? That's what we coded it to do. But in this case, we basically need some way of making that work, right? We need some way of getting the code smart enough to know that sometimes we want things to pass through things and sometimes we don't. And maybe we even want something as complicated as whether or not something can pass through something else is dependent on which two things collided, right? You could imagine that certain entities can pass through magical doors and others can't, let's say, right? So we may have a situation with collision detection where even just the notion of what can pass through what is entirely a gameplay decision that involves a bunch of logic, right? And that's the kind of thing that we want to take a look at today, right? How do we enable that? How do we make that clean? How do we make it so it's not all janky and hacky? Again, our collision detector isn't a final collision detector, so there's plenty of problems with just a collision detector because we haven't really written a full one yet. But ignoring those problems with that, I'm just talking about the logic of what happens. We want that to be nice and clean so that the logic is generally flawless. So if the collision detector itself, when we actually make the bulletproof version of that, it's not hamstrung by the fact that there's all this kind of weird, not really that reliable way that things do or don't collide. And we end up having all these bugs in the shipping thing where it's like people report, oh, well, I tried to fire the thing and it disappeared halfway through because of something, like weird, like collision-y bug sorts of stuff. So we want to make that code work in sort of a nice way that's not going to cause us problems and that we can add things to when we need to, and it's not this huge deal to add them, right? So basically, the first thing I want to take a look at, and I think we've got our important in here, yeah, so need our collision table here. So the first thing that I want to take a look at, I'll delete this to do because it's basically what we're doing today, is we sort of started on this handle collision path, and what we do is we have a collision thing here, and we've got this stops on collision thing, right? And we were sort of saying like, okay, the flag that says whether an entity collides is telling us whether or not when an entity hits something, whether it stops or not. And so the first thing that I'd like to do today is let's go ahead and change that concept, right? And say whether or not something stops on collision, let's just make that a factor that gets computed in the collision. So basically, we don't even have to change the rule right now. We could make it so that essentially we get sort of a thing in handle collision, right? We can make it so that we sort of do it the same thing in here. And so it's still based on that flag. But I just want to make it so that it could be procedural if we wanted to. So stops on collision is now going to be something, right, that gets done in this particular call. So something, you know, like this. I'm not saying this is actually how we should necessarily do it, but something that looks like this, where when a collision gets handled, whether or not the collision handling code said so is what will determine whether we stop the thing from going in the direction it was going, right? So that's step one of the process, right? And that's a pretty easy step to do. The other part of the step is taking a look at sort of the bug we already have now, and that I actually talked about solving this way back when we started this, and we kind of decided to go off on a tangent because I wanted to fix a bunch of things with how we did things. So we did the sim region stuff. We inserted that in there because it was the next logical thing to do. But way back when, I talked about the concept that we kind of want to have a more robust way of thinking about when entities hit each other. And just to refresh your memory for people who didn't basically have that sort of down necessarily, let's go ahead and make a little space here. Where are we in our whiteboard? Is there day 68? Let's go over here. Oh, I guess I kind of need to zoom out. I wish, is there a way to like remember what the current zoom level is? I don't actually know. I guess not. So here's our whiteboard. Let's go find a location. Oops. Let's go find a location that would be fine for this day. So I'll just zoom in over here, right, for day 69. Let's say it's right here. I guess this is probably, is that probably how big things were before? I don't actually know. So let's go over here. I need some way of remembering the zoom level. Is that a thing? Is that this? 100%? Okay. So I guess I just want that to be 100%. Is that what that does? No, that's opacity. So I don't know. Is there even a zoom? I don't actually know if there's even a thing that, that says what the zoom should be. I'm not sure. I really don't know. Erasers, presets, that's just all brush stuff. View, yeah, I don't know. If somebody happens to know, write it on the forums or tell me in the Q&A if there's any, in this thing, if there's any way to like save the zoom level. That would be kind of nice. Anyway, here on day 69, let's go ahead and talk about what I was saying before. So what I was saying before is the approach I'm going to take first to this problem is, all right, so I've got Mr. Hero here, and he throws a sword at, and then there's a Monstar right here who's, basically like mad or whatever. And the sword's going to go, it's going to hit the Monstar, right? So this is a Monstar, and this is a hero, and this is a sword. And so what happens is our collision routines, all their job is to basically take some representation of each of these things and tell us when they hit, right? It's supposed to basically say, okay, if this is traveling in this line, then I know that at this particular time, when the sword gets to here, it's going to hit this Monstar. And when the sword starts out, if the sword started out here, it's touching the hero, right? So what I want to do is be able to write logic that basically says when a hero throws a sword, I don't care if it hits the hero. Don't consider that a problem, right? So I want to be able to say things like, okay, hero versus sword, ignore that. Don't even think of that as a collision. Don't even think of that as a possible collision when this hero throws this sword. Now, I don't want to say necessarily all heroes. I want to say this hero, right? So it's specific. It's not necessarily a type. It's not about the fact that he was a hero. It's the fact that he's the guy who threw the sword. If the Monstar threw the sword, it'd be the Monstar that I don't care about, right? So this is a specific object. This is an entity, I want to say. And this is not all swords. If there's another sword that's coming at the hero, I want to know if they hit. So I want to know this sword, right? I want to say this hero versus this sword, don't do that. That's just a logical, that's what my brain wants to say. Similarly, when this Monstar gets hit with this sword, I then probably want to say, all right, if the sword at that point is done, meaning if the sword is like a one-use thing, it hits a Monstar and then it disappears or whatever, right? It shows some damage effect and the sword stops, goes away, goes back to the hero essentially so they could throw it again, whatever. That's fine. We don't have to do anything because on that collision the sword goes away, there's no more logic involved. But if the sword is to continue through the Monstar, so it's a piercing and has like a piercing property or something, so it hits the Monstar, it does damage to the Monstar, and if there's another Monstar, if there's Monstar 2 over here, right, and maybe this is a really evil Monstar. Maybe this is, let's say that this is actually a super evil Monstar. So it's like a mimic. It's a thing that pretends to be other things and then attacks you or whatever, right? What was the name of that? Oh, you're right. It's the superfish monster, right? It pretends to be something else and then it attacks you when you least expect it. So there's another monster over here and we want the sword to go through it and hit this guy. So once it hits this dude, every frame thereafter, our collision detector would keep reporting that hit, right? If we didn't do something about it, and that would be problematic for our collision code because every frame it would think it hit the Monstar, it would think to do whatever it's supposed to do when it hits the Monstar, and if that's like subtract a hit point, it's going to take off as many hit points as frames as it goes through the Monstar. There's all these problems, right? So we have issues there. So the other thing that we want to do is once it hits a Monstar, we won't want to say like, you know, on hit, Monstar versus sword, right? And again, it's this Monstar versus this sword, right? Ignore. So that's another thing that we want to do. And so essentially what I'd like to do here is I'd like to try, and again, I've never actually written code this way before. It's not something I've actually done. So I'm kind of interested to see how it works. And I oftentimes will be doing stuff like that in the stream so that you can see how I work through new problems, not just problems in the same way that I've done them in some other way, in some other case. So the thing that I was thinking about to try first for this, and I explained it on a previous stream, is let's just make this explicit. Let's just go ahead and actually just write code that does exactly this. So in our collision response routines, and anywhere else we want, like when you throw a sword, you can literally just add rules to the system that tell you this, and the collision detector will obey them. So when a hero throws a sword, we add a rule that says this hero and this sword can't collide. Right? Let's just do it. And then we'll see how that actually goes, right? That's my theory. And I don't know how well that'll work, but it seems like a good way to start. Because usually, if you can make code explicit, if you can make it do things the way that you want to state them directly, that is usually the most versatile, most easy to understand, most easy to debug way, because then there's not all these weird implicit rules that you've basically tuned, you know, code that you've sort of crafted to do essentially what we just wrote, but in an indirect way. So I'm going to try that, and that's going to be the topic of today's stream. All right, so let's take a look. How are we going to do that? What I want to do is basically do that right here, okay? So we already have essentially one implicit rule. We already did sort of one part of this, which was saying that when I test an entity, I don't want to test the entity against itself, meaning an entity cannot self-collide. So what we did there is we said, all right, when we loop through for any given entity, right, here we are in our move entity routine, we're moving this entity, this is called entity. When entity moves, we loop through the other entities that we want to test, called test entity. And right now we don't have a spatial partition, that's why we say spatial partition here. We're looping over all the entities in the sim region, and later we probably only want to do the ones that are close to you. But that's neither here, that's an optimization. That has nothing to do with the logic, that's just an optimization. So what we do is we then say, if the entity is not equal to the one we're testing against, if they're different entities, then we'll do the test. But if they're the same entity, don't do the test. And that was sort of one of these rules, essentially, that's universal for all entities. We don't want them to collide against themselves, because that's a meaningless statement, right? Obviously, an entity always is colliding with itself, so if you had something you wanted to do on that condition, you just put it in its update call, because you know it's always going to happen. You don't have to test for it, right? And so given that placement, what we really want to do is we want to upgrade this to basically say, should these entities collide? So we want a should collide call, right, which takes two entities and figures out whether those two entities should collide with each other. If it returns true, we'll assume that we actually do want to do that test. If it returns false, we'll assume that it wouldn't. And what we can also do is roll this test in there, right? So basically, the collision detector now will be completely dumb as far as any is concerned. It will just call out to some kind of grand notion, a predicate function basically, that's just there to know whether two things should collide. And in that way, anywhere else in the code that we want to know whether two entities could collide or not, if we have logic that needs to know these sorts of things, it can just call that same function, and then we know everyone's always asking the same question. They give two entities, and they can get back a yes or no answer whether or not the two things will collide, right? And so that's what we want to do there. Now, we have one other and I guess we have one other thing that doesn't address, which is, whether things stop on the motion or not. But that's the job of the collision response routine. So we're breaking into two pieces. There's whether or not we want to register the fact that they collided, and then there's what do we want to do on it. And what we want to do on it is handled down here. So this is strictly telling us whether an event could occur when these two things touch, and that event could be about physically colliding with the things, but it could also be that they're just passing through, but we want to note it, right? So that's what we're going to do here. So if we take a look at what this should be, we already know potentially one of the things that it should do, right? So if I take this out here and say, should collide sim entity A, sim entity B, right? Then what I could do is just start by saying, well, we know one thing, which is this, right? So let's go ahead and move that out there, like so. Okay. All right. So basically, we know that if two things are going to do colliding, right, then this collides flag, I don't know how much we want to deal with that anymore, but we know at the very least both of these things should neither of them should be non-spatial entities, right? In other words, both entities have to be spatial in order for the things to collide. And that gets us out of that business, essentially, of testing this. Now, we could still do this here as sort of a special case, if we wanted to, where we basically are quickly getting out of this routine. So we could say right here, note, this is just an optimization to avoid entering the loop in the case where the test entity is non-spatial, right? This is just an early out, but we really don't need it anymore, meaning we could get rid of that and the code would still function properly, but we may just want to do a little pre-checking there to see, right? So anyway, we've got this test. We can basically say if either of these two things are non-spatial, then we know that we wouldn't have to do this. But if either of them are, then we need to actually do the check. All right. So we got our results here. We assume that they don't need to. We return true, assuming that they're both spatial, and then we return that, right? And so that would be one way of us testing that. And again, that should just kind of work and do the same thing that we were doing before. Okay, we still have our stops on collision thing, so that would be this, right? But yeah, on the stops on collision front, we don't really quite know how exactly, we haven't talked about how we want to deal with this yet, but we could say that basically it's not really about the entity flag anymore. We could say that stops on collision is just whether, I guess we'll do the A type equals entity, handmade .h, handmade simregion.h, there we go. The things that stop on collision are basically the hero, right? I guess. And let's see here. You get, this is not the way we want to do this. I don't even know why I'm typing this in right now. I just kind of wanted to go do the other thing. So let's see, the familiar and the monstar, right? Familiar and the monstar, right? Those are the things that stop on collision. And we did this kind of sorting thing. I don't even, you know what? I'm not even gonna do that yet. That's not even the way we want to write it, so I'm just not even gonna do that. We're just gonna return false for now, and then the next thing we'll do is we'll come in here and do that. So let's do real stops on collision, because that's gonna be an entity property comparison thing. So I don't want to pretend that that would be something useful to write. Okay, and so what we need to do now is actually kind of build these things out and make something logical about, go on there, right? So let's tackle this one piece at a time. What we do know is we want to have a way to write these rules that I talked about in the whiteboard. We want to write that into the should collide function. So basically what we want to do here is say, you know, in this section, we wanted to do, that'll basically do look in a rules table to see if we should collide, right? And that'll be that. And then the other thing that we want to do is probably we want to sort of formalize this handle collision thing here so we can make the stops on collision thing a little more logical. So on handle collision, I'm trying to think of whether I just want to return that Boolean, whether a Boolean is sufficient, or whether I want to return a package of information that says what should happen. I guess for now, since I don't know, I'll just leave it with the Boolean. But in the future, maybe we want to return a little more information there. I'm not sure. And so I'll also move this to do for stairs up here, because really that will be something that happens in the handle collision when we actually handle stairs and stuff. So I think this will be fine. But what I would like to do is the sorting stuff. I'm going to get rid of the sorting stuff in here. I'm going to move the sorting stuff that basically was about doing the dispatch. I'm going to say that handle collision actually just takes the things directly, right? And we'll deal with that kind of up here. If it wants to sort them, it can sort them. And so handle collision will just pass the two entities into it. Like, so what are they? They're entity and hit entity. There we go. And so basically, yeah, there we go. Basically, this is the setup that I think that I want to use to go ahead and write the code. So the way the code works is when we are moving an entity, at least at the moment, we go through some number of iterations trying to move them to the new location that they should go. We have a movement cap, which we implemented yesterday. So I can only go a certain distance if they've got a movement cap on, but that's a separate issue. So what we do is we go through all the entities and we say if these two entities should collide, then we actually test to see if they could collide, and we set the collision time based on that. Then we come out here. If we actually did collide with someone, we handle that collision. And if that collision handling code decided that we should actually go ahead and stop the thing where it was, we will update the delta to not allow them to move in that direction anymore. And then we continue our iteration, right? So very, very straightforward. And so now basically all of our stuff is broken into these two sort of routines. I'm going to put them in the opposite order because this is how they actually logically are organized. We essentially have one function that needs to determine whether checking should occur at all. And then we have another function which basically says, okay, what do we do when two things actually do collide, right? So let's start with the should collide. Anytime two things are spatial, we're basically saying they can collide. And so then the other thing that we're going to do here is basically look for any rules, because I think that's all we have right now. It's basically like two things should collide if both of them are spatial. I can't think of anything right now that we have that doesn't actually at least have events that happen on collision, because the sword is something that passes through things, but we want to do stuff on it. So everything in our game so far collides. And so all we really need at this point is the table. And so I'm going to do a very simple version of the table first, but we're probably going to want to do a more complicated version of the table in a little bit. Something that's a little bit smarter than this. This is going to be like a really stupid version of this table, right? But I'm just to get it working so that we don't have to think about it too much, because we probably want to organize it to be fast, and this ain't going to be that. So all right, so basically what we've got here is we're going to have a little collision rule. So we'll just basically say there's a collision rule here, and we'll call this a pairwise collision rule, I guess. And so what this will be is this will essentially say we've got you know, an ND index, storage index A and storage index B, like these two guys, right? And we're basically saying that they should or shouldn't collide, is what I would say, right? And so for now, I guess we'll just store a bool should collide. And so what we want to do is basically look this up. And I'm going to do the dumbest, like I said, dumbest possible thing. We'll have this pairwise collision rule. I'm just going to sort of store, I might even store just a linked list of these things. I'm trying to think of what I want to actually do here. Because I think what I probably want to do eventually is have a hash table. And I want to probably hash on storage index A. And yeah, I mean, that's probably what I want to do. So, you know, we'll probably want to do something like this, right? Something like this. And then there's just, this is just like a hash in here that basically says we've got a pairwise collision rule. And, you know, we've got some hash table of said rules, right? And so we've got collision rule hash, right? And that's going to be something, right? So that seems fine. And I guess I don't even really care how big this is. It doesn't even really matter. I don't know. We're not really doing anything particularly intelligent here. So we'll just do the same thing we did before. Must be power of 2, right? Like so. And I'm just going to store those things in there. So what we'll do is anytime that we want to know about this pairwise collision rule thing, we're just going to go ahead and say, let's go ahead and look in that table. So this is going to have to know about our game state, right? So this is our game state here, game state. And it's going to go ahead and look in that table and say, okay, well, we'll do the same sorting that we did here, right? We'll basically do the same kind of sorting technique. We want to look up in the hash table based on a stable index for when two things are going to collide with each other. So since they're stored on storage index, what we'll do is we'll just say, if the storage index, we'll sort them so that A is always the one with the lower storage index, right? So we know we're always looking up. And if you don't, if you've never done that kind of thing before, it's a pretty standard scheme, right? I have two things. I've got A and B, right? I want to hash, I want to look up something on both of them. So I basically want to do a query which says, you know, or a map, right? Which basically maps, you know, A, B to a single Boolean value, right? And the problem with this is if I just wrote it like this, then map AB would not return the same thing as map BA, right? Those would be two distinct entries if I was just doing them, you know, kind of as whichever one came first. And since nobody knows which of these, like, you know, if we just kind of took, well, whatever the routine happens to pass as the first one or the second one, we'd have two entries, one for when they were passed in this order and when they were passed in this order. So what we want to do is make sure we always pass them in a stable order, and the easiest way to do that is just to compare some known value in them and swap them around so that we know they always get passed no matter who passes them in the same order. And so that's what I'm doing here. I'm just basically saying, okay, let's swap them so they're always in the same order, and then I'll look up in that hash table to see whether there's an entry for these two guys, right? Hopefully that makes some reasonable sense. So we're going to do should collide. We swap the things first so that we know that they're always in the right order. And then what we do is we take a look into the table, and we could actually say perhaps even that the table is authoritative for now, which is if there's an entry in the table, then you use that, otherwise you don't, right? And so we'll just say for now, we'll do a found. Actually, I guess we could do it, we'll do it this way, where we do it afterwards. So we'll go ahead and say, all right, let's take a look in that collision rule hash. We'll basically say, we have a hash function here where we basically say, you know, we have a hash bucket, right, for this guy. And I've already gone over hash tables, so I won't belabor that point again. We're doing exactly the same thing we did before. We'll just take the storage index of this entity. We won't even bother trying to do any kind of hashing on it yet. We'll put in the thing that I always love, although we may never do it, with better hash function. It's in every code base, and no one ever actually has to do it because hash tables are so darn fast. Compared to everything else in your code, oftentimes you never bother going to write a better hash function, but you know, it's there. And then we go ahead and we'll say whatever that size of the hash table is, right? Collision rule hash. We'll go ahead and that with the value. So that produces that mask for our hash table there, right? That basically wraps us into the hash table. So we go ahead and we get that rule out. We've got our pairwise collision rule, like so. And we basically want to loop through that. In fact, I guess I could do this with a for loop here. So we start here. We keep going. Rule equals rule, next in hash, right? Next in hash. And in the case where whatever the rule is, storage index A equals a storage index, right? So if I find a match, just looking for that match, if I find a match that has both A and B in it, then I just assume that the result is whatever the rule said, right? So the rule just straight up overrides whatever I might have computed in whatever this logic ends up to be, right? So to do property-based logic goes here. So basically, like, we probably want to make this more complicated than it is right now, eventually doing things with entities to determine whether they should collide based on some properties of the two entities. But for right now, we don't have that. We don't have any really rules we want to implement, but they will go there eventually. So assuming that we already set that to something, then what we do is we'd go ahead and check in our hash table, look through the hash table, right? Grab out the first one that's in that whatever bucket we should be in, hashing off of A, go through each of those rules, and when we find one that matches, we just override it. And in the case where we find a rule that overrides, we just stop, right? Okay. So we kind of have, there's a nasty thing here. In fact, I'm kind of glad we started down this route, actually, because this is going to kind of be an interesting programming problem, because there's a thing that I haven't actually considered here when I started writing this that actually is going to make this a more interesting data structure than just something that we've done before, right? We actually, technically, have a problem in terms of who we want to look up on. Because when we add these rules to the system, right, we kind of want also to be able to pull them out based on the entity as well, right? We want to be able to say when this sword is done, comes out of existence, it doesn't really come out of existence, but when it goes back to the player, we can get rid of all of those collision rules that were on that sword, right? And so we kind of have to think about how exactly we want that pull, that sort of removal, to work. And so there's a couple different ways that we could do it, obviously, but it's kind of a tricky problem. Like, I'm not sure what the most efficient way to handle that would be. One way is to thread it again, so we basically can pull things out by an entity thread. So in addition to being linked by hash, you're also linked by entity. But I'm trying to think if there's cleverer ways of doing that, and I'm not entirely sure. So for now, we'll just start with that. We'll finish getting this working, but then we'll have to think about whether we want to kind of upgrade sort of how we're storing that, because we want it to sort of be able to do both things. And we'll see. If you don't know exactly what I'm talking about, it's okay. We'll get to it in a second here. So there's our should collide, right? That basically tells us what should be going on there. And so, we now have a trivial way of avoiding two things from colliding with each other in that particular case, right? And so I think that actually should be mostly what we would need to get started with this. Collision rule hash, is a member of game state. Let's see here, storage index A. That should just be storage index. And then our should collide takes the game state now, like so. But of course, this guy doesn't have that. So this actually takes the game state as well. There we go. Which means we have to pass it here, like so. So there we go. And now we're, in theory, actually checking this stuff properly. Oh, well, but of course, I can't just randomly change my memory layout. We don't support hot loading on memory layout changes at the moment. So yeah, so now what we want to do is we should be able to add a rule that would allow us to stop having that weird bug where we kind of get stuck in there. And we could also make it so familiars can pass through the hero now pretty easily by making it so that familiars can pass through the hero but not other stuff. That would also be something that we could add pretty trivial, like this familiar can go through this hero and so on, right? So let's see how we can actually add that. Let's see how we can do that with our pairwise collision rule stuff. So now what we need is we need a way to add that. So we've got our should collide, right? Sim region. we've got our should collide call. We also need a way to basically say, add collision rule, something like this, where we can basically pass in this and say should collide, and now that collision rule will, get added to the list. It's the exact same thing. Like, we're just going to grab that hash bucket out. We're going to look to see basically which one there is. And unfortunately, I guess, I don't know if I want to share this code or not. It's such a small piece of code, but maybe, we kind of want to share that. We'll see how it goes. What I want to do here is say, all right, when we add that collision rule, I'll at least do the due diligence and assume that, that could already be in there and that you're just trying to override an existing collision rule so that I won't keep adding new rules. I'll look to see first if that rule is there. And I guess I need to do this as well to make sure that switch happens. I'd like to pull that code out. I don't like the fact that that's duplicated. So we probably want to get a little, we probably want to collapse this to do collapse this with should collide. And so we'll have to think about exactly how that's going to go. But anyway, when we have the A and the B's, we'll do the same sort there. We'll look them up again. And basically what we'll do is we'll see whether or not we found it. So we'll do pairwise collision rule found equals 0. When we get here, we'll do found equals rules because we found it. And then if we do not find one, we will go ahead and add one. So we'll basically say that, whatever's in the hash bucket right now, we just need to do that chaining. We're doing this next in hash thing, right? We're basically going to go ahead and chain that on there. So what we'll do is we'll say if we haven't found one, then we're just going to make a new one. So we need to do one of our pushes here, right? We need to do a push, and then we'll basically get a new one out. And then what we do is we say whatever was previously in the hash at that location, we push that down. The new entry that we're going to put into the location here is going to become the first one, and we'll point to whatever one was in there before, right? I'm doing that standard thing where basically we've done exactly this sort of thing before, right? I have a table of pointers here, right? This is my hash, right? Each one of these is 0 at the start. When we go to add something into it, we take whatever the pointer was that was there. We're going to put a new pointer into its place. We're going to make a new thing, right? We're going to put a new pointer into its place and point to whatever the first thing was. Now, if there already was something there, then when we set the pointer equal to some new thing, we need to make sure that this guy gets saved. So we make the next pointer of the thing we insert point to whatever was there before, right? So we're basically inserting at the head. We always insert in between, at the head of the hash table, in between, we basically insert right at the beginning so that everything that was there before just kind of gets pushed down, right? Pretty simple. So the next thing in the hash is going to be whatever was the first thing in the hash before, and then whatever the head pointer of the thing points now to us, right? So we overwrite whatever was the thing that was there before the pointer to it. We overwrite it with a pointer to ourselves, right? So all we really need now is to actually go grab that arena. Again, we can use the world arena for this because this is sort of a permanent thing that stays around. These rules are important to the gameplay. So we've got our world arena. We can push into the world arena something that is the size of a pairwise collision rule, and now we've got a new one, right? Like so. I believe that's all we need to do for that. Push, what is it called? I don't remember. I never remember what we called that. It's called push struct. Yes, push struct. There we go. So we do our push struct, we get the new one, and then assuming that we, at this point, we now want to assert that we definitely have one, right? Although we could actually do an if found here to allow out of memory scenarios, which, like I said, we haven't really gotten to how we're handling memory policy yet, so it's not that big of a deal. We'll look at all our push structs later and decide how we want to handle it, because there won't be that many of them. And so basically, assuming that we found it, we set its should collide equal to the should collide, and we set its A and B equal to our A and B as well. So this is storage index A, and this is storage index B, and so storage index A, and storage index B. So I think that's all we need to do really to add a collision rule. And so let's go ahead and check that out. inside our handmade.cpp when we actually create the hero, right? So when we do add player, like so, what we could do is say, all right, when we add a player, let's go ahead and say that, because I think, don't we add a sword? When do we add the sword? There we go. We add the sword. So when we add the sword, let's go ahead and add a collision rule that basically says that whatever our sword was, oh, you know what I just realized too? This should actually probably not be, we don't want to have these in the sim group. Like we want these to just, we actually want this to just be storage index A and storage index B, because we want to be able to call this outside of simulation. We want to be able to call it at any time. So really, we don't want this. We just want it to work this way, right? So we have storage index B, storage index A, and then we have our temp equals storage index A equals storage index B, and then storage index B equals temp. Right, so we swap those around. So then these become this way instead, right? So that way we just don't have entities anymore, and that's nicer because now we can call it from anywhere. So basically we have at that point, we have our sword low index and our hero low index as well, entity.lowIndex, like that, and we pass that game state in there, and then we say that those two things should not collide. Right? And in theory, that might work, but who knows? We'll find out. So I still am colliding properly. Of course, our collision detector is awful at this point. We should really probably go in and just fix that collision thing so people can't get stuck in things. But yeah, so we got a bunch of work to do to fix that sort of stuff. We'll look at that in a second. But basically now we should get into a situation where, yeah, that thing does not collide anymore. Of course, it does collide with the tree, which creates a problem for us, because now the thing can't get past the tree, which is not what we wanted, but that's a separate issue. All right, so let's go fix that problem. In fact, I guess we can fix it probably without actually doing anything here. All right, that was pretty funny. So when two things should collide, we could also say that basically inside our handle collision, if any of them is a sword, then we don't want StopsOnCollision to happen. So actually, now that I think about it, what's going on here? Oh, I see. So I guess I see what sort of the problem is, right? When two things hit each other, we don't actually have a way of saying, okay, we want this thing to go through. So when StopsOnCollision is not true, at that point, we essentially have a rule that we want to obey, which says these two things, this should pass through, right? This thing should pass through the thing that it just hit, if that makes sense. Okay. So we can do that. We've got issues to deal with now at this point, but let's go ahead and follow this through to its logical conclusion. So we'll add a collision rule here. We'll say, all right, we've got the game state. The game state is going to say from now on these two entities can't hit each other, so entity storage index and hit entity storage index just can't collide, right? And so we'll just say that that's true, right? And there, hey, look, our sword goes right through stuff now. Now, of course, we're not sorting yet, so it doesn't draw on top of them or anything like that, but now it works. But we've got a slight problem here, which is that we're kind of, again, this is the part that I was talking about before. We have this problem where we don't really want to keep accruing these collision rules, right? Because as we do this, we'll just add more and more collision rules as the sword goes through more and more things, more and more different entities, right? We'll end up in a situation where we just fill up our entire memory. Well, maybe not, because memory is huge these days, but just in terms of thinking about it from a more efficiency standpoint, we don't really just want to add collision rules so that we eventually have a rule for everything that the sword has touched ever and gone through and all that sort of stuff. So what I'd like to do is I'd like to be able to remove, I threw that, I was going so fast that it actually ended up going backwards, which is pretty funny. That's pretty funny. It's going to take that guy a while to disappear because of how slow he's actually moving. Come on, go, I want to throw another one. There we go. So what we want to do is have some kind of a sane policy where we basically say things that are doing this sort of behavior should have some time when their collision rules get cleaned up. So as we add things when they go through, we won't just accrue them forever. That seems like a better idea, right, than doing it this way. That's just my assumption. So yeah, so now everybody can go through everything because everyone has that false, and we're just accruing collision rules like crazy, and I want something to stop that, if that makes sense. However, one thing we also can do, let's go ahead and exit there. One thing that we can do first is we can make this handle collision call actually do stops on collision in a slightly more meaningful way. We could do it where it basically says, okay, if the A type equals entity type sword, then stops on collision is false, right? Stops on collision equals false. Otherwise, stops on collision equals true. So basically everything but swords have to stop. And we'll talk about, we'll figure out what's going to happen to other stuff later. But now at this point, in theory, I should still stop, right? Which I do. But my sword won't stop when it goes through things, which it doesn't. And so that's good, and everyone's happy about that. Okay, so I think we're in good shape now. And of course, our Monstar also sort of works to some degree. But of course, we get that collision rule thing happening. I don't know why did that was pretty interesting. Why did our sword disappear the first time? Oh, because it does this. We have a rule in there for make entity non-spatial, but we want to actually, when you hit a Monstar, we wanted to say that it does stop at that point, because that is how we were actually doing it, so that we wouldn't add that rule, right? That makes some sense. Yeah. Of course, we don't actually want it to do that. What we want to do is leave it spatial and have it just go through. So we want to actually do that. But I just thought it would be interesting to see what would happen there. So now we should be able to fire the sword through the guy, and you'll notice that even though, yeah, there we go. This is an even more serious manifestation of the problem I was talking about, which is like once we've said that the sword can pass through the guy, it can pass through forever, so you can never hit him again with the same sword, right? So that's another reason why we need to clean them up. It's not just efficiency, right? It's an actual rule that we don't want. We want to say that that rule only exists for when the sword is essentially in flight, right? And when the sword stops, we want to reset its collision rules to be null. And so that's the next thing to think about, right? As part of this system, how do we want to handle that? So if we want to have this sort of flexibility where we can just add these collision rules, we also need the ability to pull them off, because essentially when we did that processing here, when we were basically saying, okay, the sword becomes non-spatial, right? We've got the simulation for the sword. We say make entity non-spatial. When that happens, we want to clear out all of its collision rules, and then when you throw it, we want to put them into effect, right? So when we throw it, you add collision rules to it, and they get accrues them over time, and then when it comes back, we want them to go away, right? So we want to do something like clear collision rules for, right? We want to do something like this, game state entity storage index. And then when we do our add collision rule for the sword, we actually want that to be when we throw it, right? So when we do our D-sword, and we go ahead and we actually throw that sword, we want to do it here. When we make the thing spatial, we want to add the collision rule that basically says, okay, the entity that's throwing the sword and the sword itself, those two things should never collide with each other, right? So that's what we actually want to do. But clear collision rules for is kind of a nasty problem, right? And we should try to think about that. So we've got our add collision rule, and we've got our clear collision rules for. These, by the way, should probably go, they don't really belong here. They're not about sim regions at all. So basically I want to do this sort of thing, storage index, like so. So I'm going to go ahead and pull these out, add collision rule 4, like so. I'm going to go ahead and pull these out to here, right? And this is the sort of thing where double indexing is kind of nice, right? If you imagine you have a more sort of built out system, so you're thinking of things more in terms of a database, and you've got systems that you use for this sort of stuff already that you've written, this is the kind of query that's much easier to do, and we're having to write it ourselves. That's just part of the writing everything from scratch. You have to write everything once, but it's something that's worth pointing out, right? That querying on one or another thing is something that like systems oftentimes will make easy, like a database makes that very easy, but other kinds of structures often make it kind of hard. C++ style coding in general often makes it hard, and I'm not talking about object-oriented programming or anything like that, but just the way people tend to write things in C, where you kind of have the index as primary and it stores the things. They typically don't tend to have being able to look up on two different things. That tends to be kind of a harder thing to write. Whereas if you're used to using, say, MySQL or something like this, it's an easy thing, right? You can just say, I want an index on both of these things. So it's just worth kind of like noting that this is one of those double indexing kind of problems, because what we'd like to be able to do here is say, well, I don't actually care which of these two the sword was. I want to remove all of them, right? I'd like to remove them all. And so there's a couple ways we could approach this. One is we could have an opinion about the sorts of people who have these rules and just always do the hash on the proper one. Another is we basically do the hash in both directions, I guess. So we would first hash on it as if it was A and then hash on it as if it was B, which seems like a pretty easy thing to do. In other words, well, no, I guess you can't really do that either. Since it's always hashed on A and we don't know what A actually is. We don't know, like say that this was always B in the rule. We don't know what its A actually was. So there's no way for us to do that. So yeah, we would have to literally go through the whole hash table if we wanted to remove the collision rules for something, which maybe isn't a big deal, but it could be very expensive, right? Depending on how many things are in that hash table. I don't know if we want to do that or not. We can do it pretty trivially here. You know, we could do it in the very expensive way. The very expensive way is just this way, right? So we would basically say, okay, we have a hash index, right? A hash bucket. The hash bucket equals 0. The hash bucket is less than whatever the size of the collision rule hash is. And then for each one of those buckets, we then check all of the entries in the bucket. This would be searching the entire hash table. And every time we find something that actually has this storage index in it, we have to remove it, right? And so the way that we would do that is we would essentially do something like this, right? We'd say if either of the two things, right? If the storage index A or the storage index B, if either of them equals the storage index we're looking for, then we need to remove it. Otherwise, we don't need to remove it, right? And so the way that that would work is we actually want to be able to set the pointer properly to skip this particular one. And of course, like I always do, this will probably be a free store situation. So we basically have first free collision rule here, right? So anytime we get rid of one, we just give it back so that the next time someone actually uses it in a hash, it'll get used, right? So we have this collision rule. We'll say, all right, you know, we'll go ahead and we'll look for it. The sort of tricky way to do this here would basically say, instead of walking by pointer, I'll walk by pointer to pointer. So I start by saying, all right, I'm going to look to see what that first one is in the hash bucket. I will then say, all right, I'll walk as long as it's the thing that it's pointing to is not null. And so then I look to see if the one that I'm looking at, right, if this one happens to be the one that I want, right? And I'll say that my pairwise collision rule, next rule, right, whatever that is. Well, actually, I guess I don't even need to do that, right? So then what I do is I say, okay, I'm going to walk these guys. I'm going to see if I actually got one that matches. What I need to do is patch the pointer so that the pointer who was pointing to this now points to the thing that's after it, which removes it from the list, right? So I need to basically say that the pointer that was pointing to the rule that I'm looking at right now, I want to make that guy actually point to whoever was next in the hash, right? So basically the way that I'm removing these guys is I'm saying, well, okay, you know, I've got pointers, I've got like a linked list like so, right? And what I want to do is each one of these guys actually has the pointer in there, right? This is the hash table, let's say, this is a link and so on. So what I'm doing is I'm looking at this pointer, I'm saying if the thing that I point to matches, then I want to set this pointer to point to whoever the next person in the link was to skip this guy so that I can remove him from the list, right? So I'm basically saying like, okay, you know, as a pointer, right, this pointer will now point to whatever was next in the hash table. So there we go. So that's how that would remove it from the list. And then, of course, I also want to put it on the free store. So the first free collision rule. So basically, like what I'll do is I'll just store it here, right? I'll say pairwise collision rule removed rule equals whatever was the thing we removed. Now it's basically been removed. And then I can say, all right, my removed rule next in hash equals whatever that first free was, whatever was on the free list before, exactly the same way we did a free list previously. And then the removed rule, sorry, then the head pointer just points to the removed rule. So that puts things on the free list. And then we can also use the things on the free list. So now instead of doing this push struct, what we would do is basically do, actually I guess I could do it right in here. You can just say if not found, then found equals push struct, like so. And we can say this is going to be first free collision rule, like so. So I guess I can do this, split this way. So we grab the first thing off the free list. If there actually was something on the free list, then that's fine, and we'll basically just set the free list to point to the next thing that was there. Otherwise, we'll go ahead and make a new one. And then when we free them, right? And so we just use, again, a very simple scheme, and off you go. Nothing particularly interesting going on there. What is this complaining about? Identifier not found. Ah, yes, because we don't actually, we need to actually make these things be available to other people. So I'll go ahead and put them in here. Internal void, like so. And same with clear collision rules for. There we go. Other people might want to call these. There we go. Oops, interval. We haven't written any interval code yet. Internal. So that'll add things back to the free list in that case. We haven't quite finished this loop yet, though. So clear collision rules, while we go through them, we remove ones that matched. And in this case, we have done everything I think that we needed to do, probably, although I have to step through it just to make sure. Again, implementing this on stream while I'm talking is a little bit daunting and on the brain. But in the case where we didn't match, we want to make it equal to the next in hash, right? We want to take the address of that so that we can advance the pointer forward, right? So that would do our hash bucket nis. I'm pretty sure that's probably most of what we need to do. So let's go ahead and step through that and see how that worked, just so we can kind of see. But again, this is not particularly good. I guess I should also put in that to do. So to do, need to make a better data structure that allows removal of collision rules without searching the entire table, right? Because that's not really the way we would like things to go, if we could help it. All right, so there's our stuff. Let's go ahead and get things started here. Why am I not? Okay, so we haven't actually added any collision rules yet. So let's go ahead and shoot that, sort out. So here we go on our add, right? We want to do our swap because we always want our storage entity, our storage indices to be in the right order. So we always want A to be lower than B. So that's what it did, which is good. We're going to grab out that collision rule hash bucket and just take a look at it. There was nothing, obviously, because this is the first rule we've ever added. If it hasn't been found, we're going to try and grab the first one, the first free one. We couldn't obviously get one because there's nothing in there yet. And so what we do instead is we grab a new rule off of our arena, basically use a little bit of our storage space, and then we go ahead and set the pointer to whatever was in the free list before, and we set the pointer to be the hash bucket head pointer to be us, right? Assuming that we actually found it, which of course would always happen in a case where we didn't run out of memory or something. We then initialize it, so now we've got a nice rule set up, and we're done, right? So that's all we had to do there. And then presumably the same thing will happen again. Hopefully we'll get a similar situation where the storage index, no, this is going to store off a different guy. So this will still not find anybody. Again, there is no free, nobody on the free store yet because we haven't eliminated anybody. So off we go, adding another collision rule. This time it is, okay, so I think that's the sword, right? And probably some wall that it's hitting or something like that. So we want to, that's good. Now we can actually see it look for a rule, I think. Oh, no, I guess not. So I guess I guess it was 92004 that was added before. It was the hero. Yeah, too bad. All right, so there we go. At least I think that's true. I guess we should probably double check. I wasn't quite paying attention to all the rules. We should have checked to make sure that that was going into the right hash bucket there. I would have liked to have gotten that. Okay, so then when we do our clear collision rules 4, essentially almost all of these are not going to hit, right? So what we want to do is we want to kind of find when we actually get inside this loop at some point, right? So here's where we actually had a hash bucket that actually had something in it, which is what we wanted to see. So what's our hash bucket? Which one are we looking at? We're looking at hash bucket 41. And so we have collision rule hash, and we've got hash bucket. So here's that first hash bucket. And as you can see, there isn't anything next. So what we should see is this guy should get returned to the free list, and it should then write a null pointer in there. So we've got first free collision rule, like so. There's nothing in there right now. What we want to see is we want to see this guy move over to here and the rest of it get cleaned up. So it should match. It does match. We go ahead and say pairwise collision rule removed rule equals rule. So basically that rule is just the rule that we're looking at, right, which is fine. We then say the pointer, whatever the pointer was that we were pointing at, which is this one right here, right? We want that to now point to the next one, which was this. So this should now become a null, right? And it does. So that's nice. And now we want to make sure that our removed rule stores whoever was in here, which would also be null. So that's not going to do anything exactly. But then we want to push this guy in the free list, which we did, right? And so now he's on the free list. So it just moved him out of the hash table into the free list. And that's the end of that, right? So now let's make sure that that works when there's something already on the free list, which is what's going to happen here, right? We're going to go ahead and remove that one guy again. And now we want to see our first quick collision rule, right? What we should now see is when this guy gets pushed on here, it should be chained, right? So there should be the other guy should be on here, and there he is, right? And so those guys chain together, and off we go. So that looks good, but what we'd like to do is also double check that our free list removal is working. So when things want to come off that free list, that works as well. So now what we should do is we should see the opposite happen. We should pull somebody off this list. So found is going to be this guy right here. So assuming that we found him, what we want to do is advance that pointer, that first free collision rule equals the next in hash. So this could move up, right? And it did, and so that's what we wanted. So that's good there, looks like anyway. And so off we go. And so let's see if there's any bugs in that. I don't know, there might be. Ooh, that was weird what just happened there. I didn't like that at all. There was a, oh, that was probably just a stuck key. But okay, so we have a bug here. What's our bug? Push rect, draw hit points, hit point max. Oh, yeah, okay, well, I guess when we do if we shoot the guy enough times to actually make his hit points go to negative, we never actually really wrote any of this code, but we just sort of did a hit point max. You're not ever supposed to actually do this, but I should probably just double check. Since the code exists now, let's make it not do something ridiculous that's going to cause assertions. So there we go. So I think now we should be in a case where we can hit the Monstar multiple times, and we can now, so that's good. But it's not a great data structure. We didn't do a fabulous job there. That's something that we should go ahead and think about improving when we do our final engine components. I feel like that would be a good idea. So hey, guess what? We're pretty much right on time. I said I would go about 22 minutes later than we said we were going to do because I took a bunch of time at the beginning telling a story that had nothing to do with programming. And so now would probably be a good time for us to start the Q&A, and we'll still do about 15 minutes Q&A. I still like to get some Q&A in here. Just because we told a story at the beginning of the show doesn't mean that there shouldn't be any Q&A. So if you could, I will go ahead and start the Q&A like so. And if you could please prefix your questions with Q:, so I can see them, that'd be great. And if you could leave stuff that's off topic, ask those during the pre-stream. We always talk about off-topic stuff. Just come like 15 minutes before a scheduled start time, and we can talk about whatever. But for during this Q&A, please try to keep the questions to stuff that are about the programming we did today or the program that we've done on a previous day. And future-looking stuff or just questions about general things, try to move those to the pre-stream. So, yeah. Let's see. What stops us from programming a game that directly boots into BIOS? Hooks up to hardware as low as possible, basically. So basically the thing that prevents that is the fact that we all have different computers, right? This is why I keep saying that one of our big things in the future is to port to a known platform where we can actually do exactly what you just said. That's why I said probably it'll be the Raspberry Pi or something, but I don't know. I'm actually in the process of trying to get stuff like that figured out, talking to people and sort of figure out what platforms we can use for that. And because that is what we'd like to do eventually. We'd like to go ahead and pick a platform so that all of us can go ahead, everyone who wants to file it can go buy that platform, hopefully be able to like a relatively low-cost homebrew kind of platform. Everyone can buy that platform, and then we will actually do that exactly that way. The reason that we're not doing that currently is because it's almost impossible now. Everyone's machines are totally different. Do you have UEFI BIOS or not? What kind of graphics card is in there? How does it get initialized? Like, you know, all of these sorts of things are just DOS. We could have done it if it was in the DOS days. Now, in the modern days, it would just be so much overhead of trying to get everyone on the same page and writing all things just to get like USB keyboard input right would take us forever. So I didn't want to go that route off the bat. But that is what we want to do eventually. And so after we are finished with the game, porting it to a platform where we can boot directly into the BIOS is directly from BIOS into our game is absolutely something that we will do. And so I haven't decided exactly what platform that's going to be. It will probably take a little bit of a wait and see approach because we have a long time before the game will be done. But by the time the game is sort of wrapping up, I will have a very specific answer for if you want to do fully handmade Hero, where we'll go ahead and drop down that extra level. I will have some kind of announcement before then about like, here's the platform that we're going to be doing. If you want to do it, buy this platform and get ready, right? Let's see. Do I ever use function pointers? So occasionally, there's times when function pointers are useful. In this particular case, you know, the problem with function pointers is they can't persist. They're not stable, right? Function pointers change every time you recompile your program. So I tend to prefer switch statements because the thing that you're switching on persists. Like you can write it to disk and it works. You can stream it over a network and it works, even if the two binaries were compiled differently. Whereas if you use a function pointer, it's always unstable. So the only time you can really use function pointers is by building a table first and then using an index into the table. You know what I mean? So because most things you want to do in games have to be saved, you know? Saved games are very important. Network communication is important. Stability across builds is important. Function pointers tend to get used less frequently because of that, because if you use them, you then have to introduce a layer that stabilizes them oftentimes. And so usually it's just more efficient to just use that layer directly. Whatever the enum is that you were using that would have allowed you to serialize those function pointers properly, you can just not do that, just switch off the enum and it's way more efficient, right? And so it's not so much that I don't like function pointers, I like them just fine, it's that there's these downsides of function pointers for the types of code that we're writing that make it so that they're rarely a win. But that doesn't mean that they wouldn't be a win in other scenarios that didn't have those kind of constraints. Should the thrown entity have the player's direction speed added to its thrown speed and distance so you cannot catch your own throws? Well, right now we do add, that is what's going on right now, if I understand you correctly. We have, right, like if you take a look in here, when we have dsword, so the sword has whatever your speed is plus whatever the speed of the sword should be. That's how it works currently. But that's a game design thing. We don't even know that there's going to be swords in this game, right? So that's not really something we're thinking about right now. That was just how we happened to do it because someone was asking about it, and so we showed how to do it. But yeah, that's not really something that we're thinking about. I mean, it's not even a sword right now. It's a rock, technically. We're calling it a sword because that was what we were thinking of conceptually. But yeah, so we don't actually know if that's going to be something that's in the game, right? We haven't decided those sorts of things on the stream yet. So I don't really want to talk too much about how to make that work well because we don't even know. In order to know what should happen with something like throwing a projectile, you need to have an understanding of the game design, and we haven't progressed to that point yet, right? Could you explain again why you should order the entities before processing the properties? Yeah, so, well, we haven't quite gotten to where that's useful yet. But basically, we may not have to actually do that in Handle Collision. We'll find out. But basically, the reason we wanted to do that is if we end up doing a dispatch table for them, then we want to be able to dispatch based on a stable ordering of them, right? So let's say that we had, this was that upper triangular thing, right? Let's say that we wanted to make a routine, right? Called like sword hits Monstar, right? And that does a thing where you basically have a pointer to a sword, right? And a pointer to the Monstar. We don't want to also have to write Monstar hits sword, right? So really, all we're going to do eventually, and we haven't actually done it, so you can ignore it. It's not even, you can even just wait. It's not even something we've actually done yet. This is meaningless stuff at the moment. Basically, all we're trying to do is say we just want to write one of them. So what we should do is pick a universal ordering for our stuff, like sword always comes before Monstar or whatever, so that we know we only ever write sword hits Monstar and we never write monster hits sword, because if a sword and a monster collide, it's always sword hit Monstar. That's the only thing the sort is there for. It's so that we don't have to think about things in both directions. We know that we just only have one, which is when this hits that. And we know that if we had the opposite, we would flip them so that we'd still call this hits that instead of that hits this. That's all. Isn't there a potential bug in move entity if an entity happens to spend the whole distance limit, which gets set to 0, 0, and then considered as unlimited in the next frame? So no, I don't believe so, because the way that that's designed to work is that if your entity has some kind of a movement limit, you're supposed to be processing that in your update call. So you're supposed to do something when distance limit hits 0, right? Now, if we decide that we don't like that, then we could change that rule to be when you hit 0, you can no longer move at all. But we'd have to actually find an entity where that is actually important, right? And so the reason we don't have that bug is basically because the entity types, if you're someone with a movement limit, you're supposed to respond to having the distance limit run out. And if you don't respond to it, then it seems as sane a default to me as anything else that now you can move, right? That's totally fine too, because what was the limit there for? You have to have some kind of idea. It presumably was there because something happens when you stop. And so you should have an event there. And if for some reason you forgot to put the event there, then allowing it to move again doesn't seem any stupider than leaving it where it was. But yeah, so I feel like that's fine. And it avoids introducing some other constant value that's like a crazy value that's meant to indicate that you don't move. But if we find that we don't like that, we can certainly change it, right? It's trivial for us to make a constant value here that's just some special thing that's like unlimited. Can the discarded next pointers in the hash function become a memory problem? I don't know exactly what you mean, but basically, the memory. If you want to think about temporarily what the memory implications of a hash plus free list are, they have they have really nice behavior. So basically what happens is you have, if you think about how your memory gets used, right? You have a fixed amount of memory for the hash size. So there's the hash memory, right? So we'll call that H, right? And then we have the memory for the links, right? Like so. And that's basically like the size of the links times L. So that's proportionate to L, which is a variable, right? Times the size of the links. So basically the hash, to do this scheme, you basically have the hash times the number of links times the size per links. This is your memory usage, right? That's your memory usage for the hash table plus the free list to store these things. What happens is the maximum amount of links you can ever have in the system at a time, so whatever the gameplay ends up making this maximum be, that's the maximum this will ever be, right? Because it can never be more than that. Because every time one of these is freed, it goes to the free list. So once you've hit your maximum scenario, once you have a scenario where the most number of rules are in play as possible, so L max, H, plus the maximum L that are in play at any time times S, that's the total footprint. You will never use more than that. That will get allocated for you dynamically as you push out, and then it will just stay reserved from then on, right? Because every time something gets freed, it goes on the free list. When it gets used, it comes back in. So you never thrash memory, you never fragment. You're always perfectly utilizing the memory that you have. And it grows to the total maximum usage in any gameplay scenario and stops. So I like these even in dynamic memory allocation scenarios. So even if we decide at the end of this game that we don't care about a fixed memory footprint and we just want to allow the game to grow to however much memory it wants, I still like these schemes because it means that they grow to the total size they need to be and stay there, which is nice. I like that. And they never fragment. I have 2 gameplay requests. A non-Euclidean room and a monster that spans multiple rooms vertically. Are those things possible? A monster that spans multiple rooms vertically is trivial because we don't think about rooms in terms of how any of the gameplay code works. A room is strictly a camera concept at the moment. So a monster that spans multiple rooms vertically is easy, or horizontally, or any other way you want. A non-Euclidean room is definitely something that we don't support right now in any particular way. Oh wait, do we? So yes, we could support a non-Euclidean room. The way we would support a non-Euclidean room is by mapping tile chunks, by changing the mapping of tile chunks to not be in order. So we could do a non-Euclidean room. I will add that to my reminders.txt file to show how to do that. I don't necessarily want to make design decisions around that because I don't think it's particularly important for gameplay. But I will write it down, so if at some point it becomes a good time to maybe say, let's do a little bit of a non-Euclidean thing here, we could probably do something like that. The thing that we couldn't do very easily is a non-Euclidean room that wasn't an even number of tile chunks wide. I think that would be hard. But yeah, I think we could do it the other way. I think. I don't know. I have to think about that. So I wrote it down. I don't really want to make design decisions based on that because that's not a big part of this game, and it would be something that would affect other things that we could do. It definitely is something that would introduce a bunch of trade-offs. So I'd rather not make a bunch of decisions based on that. But I'll write it down, and if it turns out that it's something we could handle in the future that wouldn't jeopardize a bunch of other stuff, we could take a look at it. Are renderers reusable? Sure. I mean, that's what a graphics card is. It's a giant reusable renderer. So yeah, renderers are definitely reusable. It depends to what degree you needed to take advantage of certain aspects of the game that they were rendering to get performance. That's really the thing that determines how reusable they are. But sure, renders are often reusable. So I think that is all of the questions. I don't see any more, so it looks pretty good. Yeah. All right. Well, I guess that's the end of today's episode. Let's go ahead and wrap things up here. So we've actually done this. That's done. These are done. We did some to-dos there. So we basically, we've got stuff straightened out here, but of course I guess technically we kind of accomplished everything that we wanted to accomplish. It's just we don't have a very efficient way of dealing with clearing those collision rules for like the sword. So that's a little bit of an issue, and I don't know. So it's something that we've done our first pass. Maybe we need to think about it more. Maybe we'll let it go for a while, like I said, and we'll sort of see how things shape up as we sort of do more stuff with collisions and more gameplay. Maybe that will inform our decisions. It'll let us know, do we care about this performance-wise? Do we even want these collision rules? Maybe we handle it in a different way in the future because the game design sort of dictates that way. But it looks like we did the thing we wanted to do, which was give ourselves an easy system where we can just add and remove collision rules. That's not a big deal. And so we've done that, and that's good, and I'm happy about that. So we'll be back here tomorrow, and I'm trying to think what's the next thing on our list of things to do. I think probably what we should do is allow the Monstar to die, if you heard it, and then maybe we'll write a little bit of AI pathfinding code for the Monstar. Maybe it's time to add some pathfinding where he can find his way around, because that's a big if. And then we should probably start moving on to animation, because we've pretty much done a fair bit of specking on this sort of stuff. I feel like we're getting into the part where we would start writing things for real, like, start fixing the collision detector to be like fully featured and all that stuff. And we're kind of pushing up on that like real code boundary. And again, we're just trying to make sure everything's spec'd first before we actually take that plunge and make something fully featured. So I think maybe, we should move on and get a little bit more done in each arena and then start coming back and locking things down, because we're getting pretty far on a lot of axes. So that's good, but it also means that we want to make sure that we don't neglect anything first. We want to get everything sort of fleshed out before we really commit to doing something first, for real. So anyway, thank you very much for joining me. It's been a pleasure coding with you as always here on some morning Handmade Hero action. I will be back here tomorrow, same time, 9 a.m. Pacific Standard Time tomorrow. So if you would like to come back for some more programming, I think maybe what we'll do is start that pathfinding Monstar behavior stuff. That seems like a good place to go next, because we haven't really just worked on how we're going to do pathfinding, which is going to be an issue, because we don't have grids anymore. We've got just a free-form world. So we need to kind of think about that and figure out how we're going to deal with it, and I don't know. So that's something we have to dive into. So that's cool. Come back tomorrow, we'll take a look at that. If you would like to follow along at home with the source code, you can do that by pre-ordering the game on handmadehero.org, and that'll get you a link in your email, which allows you to download the source code every day after I finish. I upload it. If you would like to support the video series, we do have a Patreon you can subscribe to as well on here. We also have a news and forum site you can go to that has a bunch of great resources on it. It's got ports to Mac and Linux that community members have done, also a port to iOS now and to Android. So people who are looking to sort of run on other platforms, that's a great place to go. It also has a discussion forum and an episode guide that has like time-marked indices that you can go to and use. It's a pretty handy thing to go to. I highly recommend checking it out. And also there's a tweet bot that tweets the schedule. So if you want to check that out, go to the tweets. That's an easy thing to subscribe to that allows you to know kind of when the stream is going to be every week. So you can, if you want to catch a live one, you kind of know when your options are. So that's it. Thanks for joining me. Hopefully I'll see you here tomorrow morning. Have a great rest of your Thursday, and I'll see you guys later.